Hello, my dear students. Welcome back to the lecture. So now we'll find the top extra bar for all these portions. Okay. Now I'm right now here, top extra bar at one junction. So this is my one junction on grid E, F, and G. That means this particular bar we have put. For this, we are supposed to find the which one? This distribution I am supposed to find. First, you find the cutting length. Cutting length is very simple. This is 5525. This is also 5525. Half the beam from here, half the beam from here, and full beam from here. Same thing I've done here. 5525, 5525, minus 150 from here, minus 150 from here, minus 300 from here. So this will give me 10,450, which is 10.45 meter is my cutting length. Finish. So this is my distribution bar. Now coming to the number of bar. How you'll find the number of bar? It's very simple. Whatever is this length I want to take. Where is this length given? Obviously, it is given over this. So this is a length which is given 1150. So what you do? 1150, you divide it by the spacing, which is 150. And then what you do? Add +1 or +2. You have to add +2. Why? Again, for a very same reason, this is one span. Span 1 +1 will do here, +1 will do here. So 2 times we are supposed to do. Same thing, I've done it here. Where is that? Yeah. See here. Round up. See 114 means that 1150 divided by one spacing. Okay, it should be +2. See, it has to be +1 or +2. Sorry, it is +1 only. Sorry, okay. Yeah. See, sometimes I also get confused because we are finding this length. No, only this span we have taken. Completely we have taken. No, so it is only one. Sorry for that. Only one will come. Entirely we are taking. No, only one. +1 will do. Suppose if it was something on the other side, then it would have happened. Sorry for that. +1. Okay. Don't get confused. Cutting length is 10,450, 10.45 meter. So total cutting length will be 94.05 and weight will be 94.05 into 0.617. Done. Next. So one thing if you remember, when we had done this top extra bar, we took even this also. No? At junction 2 also we had taken. What we had taken? We had taken that here also we'll have to provide the bar. So that is why we have written top extra bar at 2 junction on D and E grade. So again for this also we'll find the cutting length. So this cutting length is very simple. This will be your cutting length. How you'll find that? Very simple. This center to center is given from here to here. It is 3250 minus 150 from here, minus 150 from here. The straight length will get. I've done the same thing. So directly I haven't drawn that here, but I've written it here. You see here 2950. That is 3250 minus 150 minus 150, which is 2950. Now coming to the number of bar. Number of bar, how you'll find? Again, if you want to find the number of bar, you should know this length, isn't it? This length you should be knowing. So this length, where it is given, again you have to check the drawing. So if I check the drawing, so how do I check this drawing? So if I want to check this drawing, I need to check this cross section. So this is in the grid number 1, 2, and 3. So I'll go back. Okay, I'll come here. I'll check in the grid number 2. So where is my grid number 2? This one. And what is the length given? It is 1150. So 1150 divided by 150 I've done here. See here. Round up. 1150 divided by 150 plus 1. Only one span, no? So plus 1 will do. Got it, no? Why it is plus 1? Finish. That's it. Finish your answer. Is ready. So this is plus 1 I have done. So only one span plus 1. Okay. Again, 9 numbers you will get. That's it. You will find the total cutting length 26.55. And for 10 die, it comes out to be 16.381. 26.55 multiplied by 0.617. Done, no? Fine. Next. After that, what we did? We did this one. Top extra bar at 3 junction on grid EFG. So 1 grid, 2 grid, and 3 grid. So this was the top extra bar we had put, isn't it? Here. Like this, we had put top extra bar. Now I want to find the cutting length of this. So this cutting length will be a little different because here we are done only up to here. But in this case, your cutting length will be from here to here, isn't it? So what you can do, you just observe 3250 plus 5525 plus 5525 minus half beam from here, minus half beam from here, and then minus half beam, minus full beam for this, minus full beam for this. Getting my point? No? That's it I have done. So I've done the same thing. 5525, 5525 plus, again, this is also 5525, then plus 320, 3250, this also added. So I got the center to center, but half beam will get deducted from your minus 150, half beam from your minus 150. Then you see this is 300, minus 300, minus 300, because your bar will stop here, and stop here. Okay. But still, you see what is the total cutting length you got? 13.400. If you're putting a bar from here to here, in spite of cutting also, your cutting length will be 13.44, 13.40, which means it has gone beyond 12 meter. So lap has to be provided. So practically, if you ask me, Usually lap won't come since it's a distribution bar. I told you practical on the site, it has to be something like this, isn't it? From here to here, it will be 1. Then again from here to here. Since it's a cut bar, there's no point in lapping. Since we calculated everything at once, we are getting it beyond 12 meter. That is why a lap length will come. So what we can do is we can include the lap length. But again, practically if you see in the side, they won't cut. They'll take a straight bar only. And then maybe one part, they're going to do a lapping. So having said that, I'll do a lap. Instead of this 13.4, I add a lap length. That is plus 57 into diameter of the bar I'm doing. Okay, we'll add that also, not an issue. But practically, if you ask me, usually in the distribution still we don't do. But again, sometime we'll do. I think I'll show you one image where that lapping can be done. Okay, I think where is the image? We'll see if any lapping has been done. So that lapping, whatever I'm speaking, just in case if you bring a straight bar from here, somewhere it will get end, somewhere it will get end here. And then you have to do a lapping. Okay, even though it's a distribution state, we'll do a lapping here in this way. So one lap length we have to add. You're getting my point, no? Usually we do lapping. But since it depends how the bar bender is going to put the bar, because all may not put a straight bar, no? Because since it's a top reinforcement, you may have left some, you may have some cut bars in your side. So that we are going to put. But anyhow, not an issue. Anyhow, not an issue. I'll add the lap length. You can add. Nothing difference will happen. Okay, that's it. So what I have done, 1313400 plus 57 into diameter of the bar. So my lap I'm taking 57 into diameter of the bar. Okay, fine. That's it. So this will come out to be how much? I should take this one now. I'll take this value after adding the lap. So it will be 13.97 will be my cutting length, and total will be 13.97 into number of bar into 1 it will come, and the weight also will come out to be this one. How much it is? 125.73 into 10 diameter bar is this one. Got it, no? Yeah, I think number of bar I've explained. Yeah, number of bar I think I've explained you. Number of bar is very simple, no? We'll go back to number of bar. How will find the number of bar? Again, this length we know. This length is directly given. It is 1150. So this 1150 divided by the spacing 150. So where it is, yeah, 150. Same thing I've done. See, this one 1150 divided by spacing plus 1. No, only plus 1 will come because only one span I'm considering. No, we are putting bar in this direction. So only plus 1 will come. Okay, that's it. Simple. Got it? In this way I've done, and this is the total answer you should get. Fine. So after that, again, what is left out? Yeah, next we'll go to the distribution bar at the center portion at 2 junction on grid EFG. That means this part. This part, right? This top extra we had put, no? For this, we have to do the distribution bar. Simple, no? You can do, no? This other bar we had put. Now I'll find the distribution still. This to this length I want to find. From here to here, both side it will come. Okay. Now how will find the length? So this length, whatever you are putting, will be same length what we found here. Also, right? That means this length, whatever I'm putting, distribution still top bar. So it will be same thing. That is 5525 plus 5525 minus half beam from here, minus half beam from here, minus beam from here. So same thing I did. It comes out to be 10,450. Okay. Next is 10 diameter. Spacing is 150. Number of bar. How will find the number of bar? Pretty simple. Number of bar. You know that this is 2600. That means in 2600, this is 1150. From this beam to here, it is 1150. And from here, it is 1150. It is 2600. This complete is 2600. But in this, I'll deduct the beam thickness. That is 300. So what I'll do when I find the number of bar, I'll just say this only. You select this 2600 minus 300 I'm doing because I don't want the beam thickness to come. Your bar will start from the face of the beam. From here also face of the beam will start. Getting my point? Plus when you add the number of bar, you should do plus 2y. On this side 1 and on this side, right? Because on this side also when I do, I'll add plus 1. This side also if I do, I'll add plus 1. That's it. Simple. Done and dusted. And then total cutting length will be this much. In meter it will be this much. Total will be 10.45 into 18 into number of members. And then total weight will be 188.1 into weight is 0.617, which will be 116.058. Okay, that's it. I think last one thing is left out. Fine, all another 2, 3 is left out. So many things are left out. Okay, no problem. I think horizontally we did, no? Yeah, where did we reach now? I think this one we did. No, we reached up to here, 10,000. Fine. Next, after this. Yeah. So now what we have? We have top extra bar. Okay. So that also we'll do now. Yeah. So what is written? Top extra bar at E junction on grid 1 to 2. That means now we have to find this one. So top extra bar at E junction. So this is my E junction 1 to 2 means this top bar we have put, no? Now in this direction we are supposed to find. Which one? In this perpendicular direction. This one. This cutting length I want to find. And also I want to find the number of bar. You getting my point, no? Here so much of calculation will happen. You have to be fine. It's very simple. So this is 1650. So this black color, whatever I have drawn, no, from face of the beam to here, it is 1650. So but I want to find the cutting length of this. How you will find the cutting length of this? This cutting length, yellow color. So I know this center to center is 3250. So 3250 minus half from here, minus half from here. This yellow color length I'll get. Same thing I've done. Sorry, it is 3750. I'll show you here. Okay, see here. This is 3750. Okay, you are able to see 3750. Okay, sorry for that. So it is 3750. Hmm. Yeah, I think now it will be correct. Hmm. So 3750 minus 150 from here, minus 150 from here. So it is 3450. Okay, that is done. Cutting length is done. Now come to the number of bar. Number of bar will be very simple. What you are supposed to do? This is 1650. You divide it by 150 and then you will add plus 1. Same thing I've done it here. So number of bar is, see, C148 I have taken. C148 means this one. 1650 divided by spacing is 150 plus 1 I have done. Okay, that's it. Finish. Round up you have to do. Always remember round up. Okay, fine. Now cutting length will be 3450. This is 3450. So this you divide by 1000, 3.45. And total cutting length will be 3.45 into number of bar into 1. Finish. And then the weight will be how much? 41.4 multiplied by 0.617 will be 25.544. Finish. Okay. Done. Next what we'll do? Whatever I did here, just observe one thing. Whatever you did from here. This one we did no now. I mean, I'm going with a different wait. Yeah, I'll do in this way, okay? In order to save time. I'll not draw again. Whatever I did now here, same thing will come here. Same cutting length will come, same number of bar will come. So again, I'll go on this side now. What I've written at G junction, no? Yeah. Yeah. Now I written top extra bar at G junction. This one, G junction, whatever you have done. Here also same bar would have come, no? Like this, you would have put the bar and you would have put the distribution still like this. So whatever cutting length you got here, same will remain here. So again, distribution still I've written at G on grid 1 to 3410 because previous case it was 3, 4. I just copied and pasted it here. Simple. Coming to the number of bar, that also remains same. Why? Because again, this length, both the length are same. This was also 1650. Here also it is 1650. So this one, magenta color is 1650. So spacing is also same, no? So pretty simple. That means answer also will be 12. Here also we got 12 answer. Cutting length also same. Everything. This is 25.544, 25.544. So if you had used your brain, you could have just multiplied this by 2, but will not do that. In future, when you get a chance, try to think of all these things. Okay, done. After that, what we are doing? This is done, no? Yeah, this is done. Next we have to find this one. Next is top extra bar at G junction on grid 2 to 3. That means now I want to find this here. This is junction G. So junction G, grid 2 to 3 means this 2 and this is 3. So in this way I'm putting the bar, no? So this bar already I have put and that cutting length you can see here. 1000. So this is 1000 from the face of the beam. I want to find the distribution still. So this is a distribution now. Now this is distribution. This is a distribution. Okay, good. Great. So distribution bar at D junction on grid. So how much it will be? This is 3750 center to center minus half beam from here, minus half beam from here. Okay. So it will be how much? 3750 minus 150 minus 150. Okay. 1, number of member is 1. Dia of the bar is 10. Spacing is 150. Come to the number of bar. Number of bar, can you find it for me? Very simple. How will you find the number of bar? So this is 1650. I mean, this is 1000. 1000 you divide by 150. I'll do it manually. We'll see. We'll match the answer. 1000 divided by 150. If you do 1000 divided by 150, if I do, I'll get 6.67. So 6.67, I'll take around. Yeah, I think there's some problem in the video. Anyhow, I'll repeat the same thing what I did. What I told is, uh, yeah, what I told is 1000. This is 1000, isn't it? This is 1000. You divide it by this thing, 50 spacing. 1000 divided by 150. If I do, I'm getting 6.77, which I'll consider it to be 7. 7 plus 1 will be 8 number. So I should get 8 number of the bar. Manually I did. And even in the Excel sheet also, you can see the same has come. 8 number of bar has come. I've done the same thing. Okay, plus 1. That is why round up. Why? If I had not done the round up, no, it would have shown me 7.77. So it is saying round up, so it will take the next higher value of 8 number. Okay, fine. The rest two things, no. Cutting length you got 3450 and divided by 1000, 3.45. So you need this total cutting length will be this much into number of bar into 1, and total weight will be 27.6 into 0.617. Finish. So in this way, what we have done, this portion we finish. Which all we finish? This entire portion we did. Okay, this portion also I did. Then I think this portion also I did. Okay. Other than that, we have a lot other things to do. Okay. I think this portion also we did. I'll just check out what all portion is left out. So up to here we have done. Okay. Fine. Yeah. After this, we have another. Okay. Another three, but I'll quickly finish it off. Done. Next is top extra bar at F junction. Okay. This is my F junction. So here I want to find the distribution still. That means this part we know. This part we had put, isn't it? This part we had put on F junction. I'm taking completely. Both the span I'll take. So number of bar I'll find here. So this bar I want to find cutting length on this side. Same cutting length you'll find on this side also. Okay. Cutting length how you'll find? Very simple. So cutting length we know this is 3750. This is also 3750. It is 7500 center to center. 7500 minus 150 minus 150 and minus 1 beam if I do, I'll get. So I've done the same thing. 7500 minus 1 beam from here. This 1 beam minus 1 beam from here and minus 1 beam from here. So it will come out to be 6900. The distribution bar at F junction 1, 2, 3 will be 1. Dia of bar is 10. Spacing is 150. Now come to the number of bar. Number of bar, you know that this is 3600. This is 3000. Yeah. So this is 3600 overall. Okay. This is 3600 overall. So whatever length we got, in that we'll deduct the beam. So I've done the same thing here. So this is how much where it is written. Yeah, 3600 it is. Okay. 1650, 1650 and this. So when I find the number of bar, I'll do the same thing. So number of bar will be whatever answer I got. That is 3600 minus the beam is 300. I've done the same thing. And divided by spacing 150 plus 2 you are going to do. One on this side, one on this side. Got it? So it comes out to be 24 number of bar. Cutting length will be this much. This is how much this, I mean, this is 6.9. And based on that, you got the answer, right? Getting my point? This is how you're supposed to do it. Okay. And finally, the last portion we'll do. That's finished. If you do this, entire thing is done. Top extra bar at E junction on grid 2 and 3. Where it is? Top extra bar on E junction. Top extra bar on E junction on grid 2 and 3. So this portion is speaking of. So this if I do, all my BBS is completely done. So this was the cutting length what we had. And now the distribution still this length I want to find. This length from here to here, here to here. Same on this side also. Okay. That lift portion is there, will not deduct it. It's okay. Okay, fine. So how we'll find the cutting length of this bar? So this we know it is 3750. So this is 3750 minus half beam from here, minus half beam from here. Okay. So we have done the same thing. 3750 minus half beam from here, minus half beam from here. Fine. Next, how to find the number of bar? Number of bar, we know this complete length is 2950. This black color is 2950. In that, I'll deduct the beam breadth. Same thing I've done here. See, round up. This is C201 means this value 2950 minus 300 I've done in that only. Divide by 150 plus 2 I have done. 1 plus 1 on this left side, 1 plus 1 on the right side. So plus 2. Finish. That's it. Your cutting length is 3450. So this is 3450. Divide by 1000, 3.45. Now total cutting length will be 3.45 into 20 into number of member. And total weight will be 69 into 0.617. So this will give me 42.573. Finish. In this way, the complete BBS I have taught you how it has to be done. Now, if you ask me, sir, tell me the total weight that is required in my only one floor I am speaking of, okay? Only one floor. That is only, even though it's the same for everyone, only for one floor I did. Let us say for the first floor, if you ask me what is the total steel quantity, I require 10 diameter bar. Everything is 10 diameter in our drawing. I require 3,805 kg of a steel is required. Where in my only in my first floor. But if I multiply all this by 3, because we have 3 floor, no, ground floor, we have ground floor, we have first floor, second and third. I'll just multiply this value by 3. Accordingly, I should get around 12,000 kg, because for one floor, if I'm getting 4,000, sorry, 3,800. So 3,008, I'll write it here. Okay, we'll verify. 3,805 is for one floor. For 3 floor, I should get the Excel answer according to this. So it should be 3,805 into 3. I should get 11,415. Okay, that means what do you mean by 11 ton of steel is required for the entire ground floor, first floor, second and third floor. We'll do that. How you are going to do? Nothing. Everywhere, wherever you are given this, now you make it 3 now. You have to make it 3. So a lot of work is there. Even if you drag also, nothing will happen, because it will not, but still will not do that. Okay. Everywhere quickly we'll write 3. I'll 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 write 3. So again 3. Okay. Why it is 3? You know, because for 3 floor I'll do in one sheet only. Else you can make another sheet and copy the same thing and make it as second floor. 3. 3. 3. 3. 3. Because your drawing is very typical. Okay. Everything, your reinforcement, everything is same, no? So then we don't have to worry. Accordingly, everything will change. And I think we should match that answer. Exactly. See, what was the manual calculation I got? I told 11,415 I should get. Same thing I got. 11,416. That means this is in kg. If I divide this by 1,000, we'll do it in ton. Finish. 11.41. So if somebody asks you how much ton of steel is required, this much ton of steel is required in our building. Okay. Got it, no? That's it. Simple. So in this way, the complete BBS I've explained for the slab. There's nothing left. Other than that, you'll not find any difficulties if you get a cut reinforcement, something like this in a project. Now, one thing is that, see here, same thing, okay? Only the roof portion, what will change? This is also for roof portion. I think there is a separate. This is a 4th floor slab layout plan. And according to that, the reinforcement has been given. And for that, they have given a, cross section they have given. So maybe everything is same in the cross section. Nothing is changed. For this, you try to do a separate BBS if you want to do. Okay, that's it. So in this way, I've covered everything. Will not do for this. Okay, again, same. Everything is same. There is no problem. Okay, great. So in this way, I've covered everything. I mean, first floor, second floor, third floor. Even fourth and roof is also very similar. No much changes. Slightly maybe. So one thing I'll tell you. When you come to the roof floor, this is your roof floor. So the staircase portion slab will come. Why? Because it is roof, no? You will have that mumpty level. Okay, that is why here the slab will come in the final. So here this additional reinforcement of the slab also you have to consider. Whereas here, if you're coming to the 4th floor, that is the open portion. If I come to the 4th portion, this is 4th floor, no? See, they have shown the staircase. That means there is no slab here. Okay. But whereas here, there is no staircase shown when you come to the last floor. They have given a reinforcement because here a slab is going to come. Only that change will happen. Rest all things is very simple. Again, this is all cantilever part. This is all cantilever part. So we don't, I mean, I didn't teach you, but I think you can do all these things. Nothing, whatever cutting length you used to take, no, we used to take the cutting length up to here, right? This bar we used to take up to here. But now what you are supposed to do, you have to take it up to this length. Just you have to add this offset, whatever offset. Let us say if it is 600 mm, that 600 mm you add in your cutting length you got. Let us say you got a cutting length here. From here, I'm giving a rough example. From here to here, we did no. We got something. Let us say 2.30. We got like 10.5 meter. So in that 10.5 meter, you add this additional this also you add, because this bar will pass through the beam only. Beam width will be 300, but half was already deducted. So this beam you add 300 plus this is 600. So when you find the cutting length, this additional portion you have to add, so that you will do the complete BBS of this. Got it, no? So this is a cantilever portion, nothing else. Good. So I think maybe in future, if I get any cantilever slab, I'll do the BBS for that also separately. No issue. After this, we'll do the BBS for the crank bar. Now it was a cut reinforcement. Next, you put a bar something like this. It's called as crank bar system. So for this also, we are supposed to do the BBS. Procedure remains the same, but since we are giving a crank here, so a different method or a different type of BBS has to be followed. So in the next lecture, we'll try to see that. So I hope you enjoyed my lecture up to here. I try to practice it, and we'll see you back in the next lecture. Thank you.